host for today, and I'm happy to be here once again. So, Mr. Emmanuel is going to take us to another journey in exam analysis and visualization. So, sit back and enjoy yourself. Mr. Emmanuel, over to you.
Okay, good evening, everyone.
Good evening.
I'll be taking on data analysis with Excel, and then we'll be starting from histogram. Just like I said yesterday that there are two modes in Excel. There is the old school method and there is the modern method. The modern method is what I'll be using now, which is going to be quite direct and easier for you to use and understand. And of course, to use the modern method, you also have to have the add-ins. If you were with me yesterday, I showed you how to add the add-ins. For those online, you just have to go to your insert, go to add-ins, go to store and search for Excel Miner. And for those that are using the software, all you just have to do is go to file, go to options, go to add-in, then go to analysis toolpath, add that in and click OK and it will show. And with those two, we'll be able to do the analysis we have to do instead of using some grave functions like concatenate and the likes. So from that, we'll move into our histogram. Are you guys seeing my screen?
Yes, we can see your screen.
Okay. Now let's move to histogram. We perform analysis by checking variable frequency. We need to represent the data graphically to understand them before experimenting on them. Histogram, as we have it, graphical representation from the distribution of single variables. It can also be said to be a statistical method needed to determine whether data are normal or bell shape. Now, the main essence of using histogram is to have a prescription of how your data is. Using histogram will tell you, okay, which ones are the constants, how effective can you judge the data set you want to use. And like that, let me go back to my sheet. I will change the screen now. Okay. Can you guys see my screen? Please, if you can see my screen, let me know. Can you guys see my screen?
Yes, we can see your screen.
Yes.
Okay.
We can see your screen.
I'm still waiting for it to load. It doesn't load finish. I will not be using large data sets, mainly because I don't want us to waste our time on this. I will show you how we can use all this effectively without wasting our time. So now, if you are going to perform an histogram, you will need a bin. And the bins are just the frequency you want to check. For example, we have temperature, and the temperature we have from 0 to 100 degrees, right? I want to observe how many times does 20, 30, 40, 50, or 60 degrees occur. Now, if you have installed the Excel Miner, you can just go back to your insert button, go to add-ins. It will show, it's already showing my add-ins. Now, these are my present add-ins. As I said before, I'm using Excel Miner for this course. There's also Star Plus. The Star Plus is a more advanced tool, but it also requires payment to use it. Azure Machine Learning are for those who are into Azure Cloud Computing. Now let's go to Excel Miner. Once you click, it's going to pop up like this. Now Excel Miner we have different from Z test to and another to F test and to the likes. Now we are doing histogram. As you see here now, it came with our input range, our bin. Labels is used if you are selecting the entire column. Our output range. Now they have different options that you can select from. There is Pareto, there is cumulative percentage, and there is chart output. You can pick which one you want. Cumulative percentage will show you the percentage on the entire data in which the bin variable occurs. Now let's put in our input range. Select from. So this from A1 to A20 our bin. Now the bin can be anything you set. It can be from, I put 20, 30, 40, 50, 60 here. You can put any other thing you want. And once you select it, see for sometimes it does like this. Then see now. My labels, and I pick my output range. Let me put my output range here. And I can decide to check which one I want, but let me select everything to show you how it will occur. I press OK. I'll wait for it a little bit. And boom. It brings. Now this is telling me, right? Okay. From here now, that this is not exactly what you wanted to use. Based on the fact that I clicked another thing, it's bringing me different. So what I do is change it back to my bin range, which is the okay, and 9. Now I have this. Click OK again. Now, these are the two types of chart that will come out. This is a Pareto, and this is a chart output. Now this is our, this is our cumulative. Let me separate this to show. These are cumulative percentage. 20 shows 70% of the data, 30, 35%, 40 it shows at 50, and like that and like that. So now this is what we are dealing with. This is what we want to use entirely. Of course, you now I can go back to insert. Let's see. And what this shows me now is this is how my data looks like. And this is exactly what Instagram is mainly used for. Now, of course, you can edit it using this option, but I'm not editing today. This is exactly what I'm looking for. So I just check my data. Okay. And like that, and like that. This is really what you'll be using for. Then we move to the next one, which is our moving average. Are you guys with me? Just let me know.
Two.
Okay.
With you.
Okay, let me my moving average. My moving average, it's, as I said before, moving average is a kind of tool for time series. I'll not be doing time series using Excel, but there will be time series SPSS. So for you to understand. Now, moving average deals with one column, and what it does is to check if the variable is continuous, to further much to show you to forecast the results of the future. For example, we have 10, 20, 25, 30, 35, 60 price of ice cream. Now, if I'm going to do the moving average, so the end, the graph that's going to show me is going to, if I start from 0, it's going to be moving upward. So I'm expecting the next value here to be an higher value. Now, if I want to do the moving average, I just simply go to moving average here, I select my range. Now, note that your range can only be one column. If it doesn't show, you can just add it yourself. E8. Intervals of 2. Since I'm not having much, let me use intervals. So if you're having higher data sets, you can use more intervals. For example, if your data is 300, you can use like 30 to make it short. If you're having 3,000 data, you can use like 300 and the likes. But since this is just 8, we can use an interval of 2, and my output range should be here. That's G8. And press OK. Now wait. Okay, my JR star, sorry.
And here's the game who can change
I
pace.
think my network is affecting here.
So we're back to
G8.
devastating.
Now, this is my forecast. For example, if you're using the analysis to pack in your software, it will automatically bring the chart for you. But yeah, it gives us a kind of it gives us the option of putting our chart ourselves. So what we do is just simply go to this and give it our line chart. Let me do it like this. And boom. Now this is representative of my data. What it's telling me now is my price of ice cream is increasing. So the next price that is going to occur should be higher, since it has been giving me an upward trend. So it's the main issue, the main use of moving averages to also check the trend. If you are the slides that I've sent to the main group, you should check it too, because you are moving with that. I don't want to be going back to the slide and coming back here. But okay, let me show it.
Hello, Mr. Osho. Please, can you reshare the screen? I think some people are complaining that they could not see the screen, although I can see it from my own hand here. Please, can you reshare the screen again, please? Thank you.
Okay, I'll go to. Can you guys hear me?
Yes, we can hear
I'll go
you.
to this place and
Can
come
hear
back.
you.
Okay, I'll show here and come back. Now, what I was doing was moving average. Now, I really hope that you guys already have the slides with you guys, because I don't want to be coming back to the slide. I already have the slide open in tab here, so to be coming back and be doing, I just want to okay, now the moving average evaluates data by creating series of averages of different subsets of the complete data set. It is used to calculate long-term trends in the data. Like I said, used to calculate long-term trends to forecast. Moving average helps identify irregularities in the data and forecasting where trend is heading, and forecast where trend is heading. Excel, as I said before, Excel moving average only analyze a single row and column. If you can also check it, I've already wrote the int for the interval here now.
The second half, Gilbert started on the right-hand side of the defence, gone into the middle alongside Van Dijk.
Bring to our attention.
Frida has places with him.
We're moving to sampling. Now, if you are into statistics, you know what sampling is. Sampling is the process of selecting a representative group for individual or objects from a large population in order to gather information or data about the population. Essentially, it involves taking a smaller sample size and using it to make inference about the larger population. In Excel, we have two methods of sampling. We have the periodic and the random. Let me show you back my sheet. Coming. You'll see my screen now. I'm coming. I have to be extra fast with this. Okay. This is my moving average. This is what it showed. Before I was explaining that what if, like this date now, it shows there was a little bit of change here instead of just going fully up. If it was lower than this now, I have to bring to my list that something is wrong there. As I said, now let's go to sampling.
He went to ground as if he was caught by Silicon.
Imagine. As I said, my network is allowing listening to this.
Can't see your screen. Oh.
Nation will be absolutely.
As I said, now we have two types of sampling. We have periodic sampling and we have random sampling. Sampling in Excel is a kind of situation whereby we take an interval. For example, let's say we have an 5 rows. You pick one. Network is not really very good. But let me go to.
Excuse me, are you not sharing your screen?
Please, we can't see your
As I said,
screen.
in sampling,
No, we can't see your screen, Mr. Emmanuel. Please share your screen, sir.
cancel my screen.
Yes.
Okay. I mean, I'll cancel and share. I'm coming. Since it's network. Okay. Can you guys see it now? Can you guys see it?
Not yet, sir.
I'm not sharing it now. Okay. Let me share again.
Okay, it's about to pop up. Okay, now I can see your screen, sir.
You guys can see my screen now. Does anybody? Should I continue, or is there any other problem?
I can see your screen, but I don't know for others. Please, can you guys see his screen?
I can see your screen. I can see your screen.
Yes.
All right. Okay, move on,
Can I
sir.
continue? Okay.
Yes, sir. Yes, sir.
In sampling, for example, we have two methods. There are more than two methods of sampling, but here we have two methods, which is a period and a random. A periodic sampling is when you send in an interval. For example, we have 100 rows of data, and I said, okay, I want to take a sample from 100, and I said, okay, in 5 rows, pick one. That's it. To do that, take 5 rows. To pick one, take another 5 rows to pick two. So let's actually do that now. Let's go to unit 2. Which is C, C8. I want to use periodic sample. Now, because my data is not much, let me use 2. My output print, which is F. And now you can see the results. You guys can see the result now, right? So what it did, it picked a sample from 2 variables. In number 1 and number 2 and number 3, it picked 15. In 4 and 5, it picked 20.
Hello, Mr. Osho. Please, who else can hear what Mr. Osho is saying? I can't hear him from my hand here.
I can't hear him too.
Same here, I can't hear him. Let me check.
Okay, I think my network is back. Can you guys still hear me?
Yes, we can hear you.
Thank you. I'm very, very sorry. My network is fluctuating. It seems that rain wants to fall. As I said,
Right.
okay. Thank God, I'm back again. Like this. So as I said, I picked. Let me pick 3 again. I can put 3. Press OK to pick from three rows. To pick, give me 1. Right range. Okay, wait. Okay, now since I've said something on periodic table, please don't mind me. It's my network. Let me move to random sampling. Can you guys still hear me?
Move on, we
Please,
can hear
let me
you.
know.
Yes.
Okay.
Yes, we can hear you.
Okay. Now let's move to random. Now random, what random does, we don't need to do anything here. Random, you just need to set the number of values you need. For example, I want to take a random sampling. This is 8. I can say it should give me 3. I should take from 8. It should give me any 3. If I put 3 and I change this to G6, give it okay. What it does is to give me 3 different numbers. You see that I brought 12 twice, so it gives me randomly, and it's not bound by the of just giving, and it can give me a value 2, 3 times, even 4 times, depending on how large my data is. So that is sampling. Now let's go to correlation. Please, if you can refer back to your slides.
Mr. Osho, I think someone is raising up his hand, Mr. Idris. So, Mr. Idris, I think, Mr. Osho, I think Mr. Idris has a question for
Okay,
you. He's
please.
raising up his hand. So, Mr. Idris.
Okay. I'm not on the team.
Well,
I can't
I can't see his screen actually. I can't see his screen. I can't see
Okay.
the screen.
I'll stop sharing and reshare it now. I'll try and reshare it again. Okay. Can you guys see it now?
Not
Give me
yet.
a few seconds.
You can try to share again, but not yet. I can't see it from my own. Okay, it's about to pop up here.
Can you guys all see it now?
Okay, yeah, I can see your screen. Mr. Idris, can you please signify if you can see his screen?
No, I can't see his screen. Maybe I'll have to like log out and log in again.
Okay.
Can you see his screen, sir, Mr. Idris?
No.
You can't see his screen.
Yes.
Oh,
I will log out and log in again.
Sorry about that. Okay.
I can hear his voice.
Mr.
I can hear
Emmanuel,
his
please.
voice clearly, but I can't see his
Okay,
screen.
you can hear his voice. Okay, Mr. Emmanuel, please continue. Mr. Idris, please, we are sorry about that. Maybe it is network. We'll try to share the video tomorrow. So please bear with us. Thank you.
No problem.
So, Mr. Emmanuel, continue.
Okay, now we are moving to correlation. If you can go back to your slides, correlation is a statistic measure that indicates the extent to which two or more variables fluctuate together. Now, correlation coefficient has the value between -1 and +1. And the correlation tells us how strongly two variables are related to each other. For example, if the correlation is +1, if it's +1 or from 0 upward, then it shows that it has +1 is a perfect positive correlation. Anything closer to 1 is a strong positive correlation. -1 is a perfect negative correlation. Anything close to -1 is a strong negative correlation. And if there is no correlation, you'll be saying 0. Now, there are two ways that I'm going to show you correlation. We have the functions, which I told you is the old school method, but because correlation to doesn't take much anything, that's why I'll actually show you using the function correl. Now, if you are going to do correlation, you don't need to specify the x and the y range. I mean the y and the x range, which is the two variables that you want it to be. For example, now we use my and I set my range, which is from, if I want to check the correlation, yeah, it's a correlation between our temperature and our unit load. So temperature and the unit load. So that's all it takes for you to just get the correlation between two variables. That's equals to. That's our correlation. If you say you want to get the correlation between our temperature and the price of ice cream, all we just need to do is press our pick our first range and pick our unit sold. Second range. No, okay, sorry. I want the price of ice cream. So now in this one, you know that you cannot select anything that is not numeric yet because it will not work. To give you error. Why did it give me another thing here? To give you error. So that you get your correlation. Now you can now use the old school method, which I said. I mean, the modern method, which I said, is by selecting your entire range. For example, I select this now. I can get the correlation immediately without needing to put in much any program again. If it does not go inside, we just go from A1 to C8. Put in our input, which is H6, H5, sorry. H5. And we press OK. And like that, it shows our correlation, temperature and temperature 1. So for the situation we have now, we have that okay, the price of ice cream and the temperature has a very strong positive correlation. It has a weak correlation in this kind of situation. There's a correlation, positive correlation, but it's a very weak positive correlation. Here now, with this 0.01, although there's a correlation, it's really positive. We can also say that because of there's not enough evidence, we can't really put there is correlation, but it's not enough to actually judge what kind of correlation it is. And so this is exactly what correlation does, and this is what correlation is used for. Correlation is between 0, 1, and -1. So it's +1, 0, and -1, which also leads us to our next topic, which is covariance. I'm trying to cover as much as I cover quickly. Now, if you go back to your slides, I talk of covariance. So it determines the relationship between, it's just like correlation between two random variables and how they change together. This one tells us, okay, I don't think you need this yet. tells us how this changes together. For example, suppose x and y are not, if x tends to increase as y increases, or x decreases as y decreases, then the covariance is positive. It implies that variable x and y show similar behaviors. And alternatively, the if opposite, the alternative if opposite occurs, like if x increases and y decreases, then there is a negative covariance. Now, unlike our correlation, our covariance is not bound by -1 to +1. It's just mainly determined by it's positive or it's negative or it's zero. If it's zero, there is no covariance. If it's positive, you can see positive 300 and something. If it's negative, there's a negative covariance. And then if it's zero, there's no covariance. And if you want to use covariance, it's simple as inputting our range. For example, let me put in price of ice cream. And okay, temperature and price of ice cream, which is my A1. Since I'm using A1 to B8. Okay. Now it can be grouped by column or row, but I'm using column because most of the time your data set will always come in column wise. If you were present when I was doing my H lookup, it will show you how rows does, so you can also use rows to do it. I pick up my output range, which is F6. I press OK. What it does is, now this is my covariance, my temperature, my price of ice cream, This is very strong covariance. Now, what this tells me is that there's a very positive covariance. There's a positive covariance between them because this is not correlation that has 0 and 1. So if in case you are saying you should just find the covariance, then with this answer now you can say, okay, there's a positive covariance between temperature and price of ice cream. And like that, we move to, please, are you guys with me? Hello?
We are with, I'm with you, continue. I'm with you, continue.
Now, together so that if so now let's move to descriptive statistics. I was supposed to do descriptive statistics, but I skip it. I'm going to sample. Now let's go to descriptive statistics because after descriptive statistics, we'll go to hypothesis. Now, descriptive statistics, just as it says, it describes your data for you. Tells you, okay, these are the mean. What it shows you is the mean, the average, the standard error, and the likes. No, I don't need this. And so, excuse me, let me remove this. Now, if you're going to use the descriptive statistics, it's just as simple as going to descriptive statistics here. What it does is now you can select the okay if you want to find the largest value, the lowest value. The confidence is the confidence interval of the mean. And what this represents is that 95% chance, we have 95% chance that values are accurate, or we give it a room for 0.5 percent error. We give room for 0.5% error. That's 5% chance that it's an error. Now here we just input our range. We can input a single column. We can input all the columns. It does not matter. This one I'm selecting from A to C. If it does not do yourself, you can just put it yourself. Now I want the summary statistics. I want the confidence level mean, and I want the smallest. So I pick here for this. My output range is H7, and I click OK. Load a little bit slower. I give it a little bit more time. H 7. It's 5:15. Okay, now it doesn't know. I'm about to set another thing. Okay, now we see as unit sold. Now this temperature, this unit sold. This price of ice cream. And now what the stream status gives us is the mean, the standard error, the median, the mode, the standard deviation, the sample variance, the ketosis and skewness, the range, the minimum, the maximum, the sum, the count, the largest, the smallest, and the confidence interval. And of course, because of this, I've given the meaning of all this on the slide. So you can go to the slide, you will see the notes that I've written there. For example, like the ketosis is the measure of the asymmetry of frequency of distribution. That's skewness, the range, the difference between minimum and maximum, the mode, the most frequency, the mean, the average value, standard, an estimate of standard deviation of the population based on the sample, and then the largest, the smallest, and the likes. So if you want to get your descriptive statistics about the variable, these are you could get it. Just go here and get it. So let's now move to hypothesis. Now, hypothesis is what I actually need to actually really start explaining. If you can go to our slide, is there a hypothesis test is used to determine whether there is enough evidence in a data sample to infer a certain truth about an entire population. It determines, okay, is there enough evidence from the data sample to determine, okay, is the which kind of example I want to use? Okay, let me even use an example instead of giving an explanation that will confuse you. Let's say that COVID-19, we've experienced COVID-19 2019, right? Let's say that we have a vaccination right now. They are distributing vaccination drugs. Now, out of the drugs that they've distributed, we're hearing issues that the vaccination drugs does not really work. It was a scam. So what we do is we go out and we collect a sample of everybody that's taking a sample. Let's say the population that's taking, have taken the vaccine, and then we bring this sample together. Then we decide to get the hypothesis test, and let's see if it is if the now you know that the WHO organization says that okay, the thing is working, and some people are saying it's not working contrary to what they say. So we take the sample and we analyze it and we determine, okay, is it actually working or is it not working? Now, if we have many people with we have a value that okay are more than the, if we take out a hypothesis test and we say that okay, no, something is wrong somewhere, and the people that were supposed to be, we're supposed to not have the corona after the vaccine and having the corona shows that okay, the drug is not working to some extent. Then we can decide to debunk the WHO who organization that okay, the drug you're giving is not working, get another solution. And that's what hypothesis mainly does. In the definition here is the process involves taking a random sample, analyzing its properties, and testing whether the identified characteristics accurately represent the population as a whole. Purpose of hypothesis testing is to choose between two competing hypotheses and the value of the population parameter. Two hypothesis testing are the null hypothesis and the alternate hypothesis. The null hypothesis is assumed to be true unless there is a strong evidence to prove otherwise. Now, let's say the WHO organization, as I was saying before, said that the vaccine is working. Now, we can't really prove them wrong until we have enough evidence, okay, of people that we've out of the sample that people are saying that it's not working and it's actually not working. So we have enough evidence of that. Can we say, okay, no, this is wrong. The WHO organization has done something wrong and the vaccine they are giving out is not proper. Now, right here, we'll be using 90% confidence, which is about 0.05%, which means we are able to tolerate errors up to 5%. Now, if we are going to be using hypothesis testing, we'll be using our t-test. Here we have we're using our two tests, and what we're using is two tests assuming unequal variance. Now, this is what tests come from. Now, since the variants are not the same, well, two tests assuming the same variance. There's two tests sample for mean. The two test sample for mean and two tests assuming equal variance. If this data is same thing is equal, then there is t-test for sample assuming equal variance. There's t-test for sample for mean, t-test for assuming unequal variance. Now we are going to be using unequal variance because the variance are not really equal. And we are doing hypothesis testing, we pick two ranges, which is first one, our first range, just say, okay, temperature and prices. Now, in this situation, because I don't really want to go to, I don't want to really waste much of our time, I'm not using a large data set. People that will still do the SPSS, you will still see that the people that will do it will stay expensive because they already have time to furthermore do it for us. So let's pick our first range as, I just want to show you how it works. Our first range as A1 to A8. And then let's pick our unit as C. We're using unequal variance C1 to C8. Now, this hypothesis mean difference can actually cause confusion. Now, the hypothesis mean difference can only be used when there is difference between the means. Like, for example, now hypothesis mean difference, it refers to the assumed difference between mean of two populations in an hypothesis test. Let's say we want to compare the average sales of two different stores to see if there is a significant difference between them. The null hypothesis will state that there is no significant difference, and the alternate hypothesis will state that there is significant difference. And like that, we will need, if we are going to be needing an hypothesis, hypothesized mean difference, we will need it to be specified. So you need to know if there is mean difference between that. But for here, we are picking 0. Our mean difference, we're picking our output range, which is our G6. That's okay. Let me move this up. Let's see the difference right now. Okay, now this is it. I don't want it to cover this place. Let me pick another side for it. Okay. So, look. So I don't want to cover my decision, so I have to just cover it up. So here is it. Like that, we get our test assuming difference variable. Now, if we are going to be preserving an hypothesis, for example, we want to do anything other hypothesis, I want to, after we put in our value, what we use to determine if our hypothesis is accepted or rejected is our t-test. Now, for example, if your t-stat, which is this our t-stat, is lesser than our t criteria, that's for ethyl rejects. If t-stat is greater than our t criteria, for two-tail we accept. Now, with this, if you are checking your values, right? If you are checking your values, check them together. For example, if you are saying, okay, like I said, two store together, and you're trying to check differences between the null hypothesis and the other hypothesis. So what we do is we do not reject our null hypothesis here as the if the t star is less than the criteria for two tail. Now, because this is two tail, this two times sample is now greater than this, we reject our null hypothesis. Otherwise, if this was minus and this was our normal criteria, we accept. Now, of course, I also want to show you the sample for me. Now, this one is for equal variance, and variance are not really equal. So, or let's say for two sample of mean, it will give us the same thing as our. I used temperature and unit load. It's I'm putting C1 CH. This is mean difference, putting 0. Output range A 20. And so, as I said, almost the same thing. But this is for to sample for means, and we are using variance. I think that is for enough for hypothesis testing because you will still talk more on that later. Let's move to our ANOVA. Are you guys with me? Trying to save time here.
Yes,
you guys
I'm
with me?
you.
So please let
Yeah,
me
move on,
know
move
if there's
on.
any situation. Okay, yeah. Now we are using ANOVA. In ANOVA for Excel, we have single factor. We have two factors with replication and without replication. Two factors replication and without replication. What we use is single factor and two factor without replication. Almost like the only difference here now is the two factors with replication, because what you have to put down is you have to put the row per sample, which is with replication. Now, for example, we say we have 8 balls now, and each of them are thrown out or are selected at random. Let's say we have 8 balls in a bag with different colors, and each of them are selected at random, and they're selected 5 or 6 times. That's what this row per sample means. So if they say in our data set is selected about 2 or 3 times, we have the number we have the row per sample. So what it does now is it to calculate the ANOVA data set when it's replicated 2 or 3 times, as I set it to be. But we're using single factors here, and what we do here in ANOVA is simple. We just add in what we really want. For example, if I put temperature and price of ice cream, which is A1, and I said this is a modern method, it doesn't really take much. If I was using old school method, then I have to go through different procedures. B 8. Now output range should be G. No, right, I think that G5. Now wait for it now. And it gives me my values. You can see from here it has my groups, my count, the sum, average, and the variance. Since the variance are not equal, we have the sums of square, the difference, the mean square, our f, and of course our p-value and our f criteria. Now, here, if the f star value is greater than the f criteria, we do not reject the null hypothesis. That means if this is greater than this, we do not reject the null hypothesis. So if you're dealing with a data set and you want to use your ANOVA, and you also want to determine the values or your hypothesis, if this is greater than this, we do not reject. But since now f criteria is that greater than f test, then we have to reject the null hypothesis. Whatever null hypothesis it is, and because now I'm using a bunch of data set, this data doesn't really have much meaning. I'm not using that data set. I can't really say and drop out an hypothesis right now. So this is exactly what ANOVA will do. If I'm going to show the without replicate, let me A1 to B8. And output range should be here. T24. And you see what this is what it does. Now this is a two-way, two-factor ANOVA without replication. I said that because our data set is not really two-way, so it doesn't really give us a proper value. Everything is not even complete. It's just one row it gives it. That's because it's not a two-way ANOVA. So this is ANOVA single factor, and this is ANOVA. You have your ANOVA two-way with replicate, without replicates, and single factor. So if you want to use ANOVA, as I said, you'll be needing these two pack, except you want to be going the old school method, which is using functions and formulas, and that will not really help you, because you have to take your time to start doing some other things before you do the remaining thing. Now we will be going into regression. I think I should be able to that has not really gone much. Let's move into regression. Now I'll really need you to go to our slides. Let me delete this. If we are looking at regression, in this course outline, statistical modeling. Now, regression is also part of statistical modeling. Regression is analysis is used to estimate the relationship between two or more variables. Now, mainly in data analysis, if we are doing anything on data, most of the things we do is either to find relation or to predict the value or to do a future forecast. That's what mainly what data analysis is about. You take a data set and you try and understand as much as you can about the data. You try and put the data to some analysis to check, okay, what is the future of the data, what can I get, what can I understand from the data. You take two data, you combine it together, and find out how is this data affecting this data, is this data related to this data, and what can I actually achieve using that data. Now, in this regression analysis is a statistics technique used to establish the relationship between a dependent variable and one or more independent variables. It's commonly used to predict or estimate the value of dependent variable based on the value of independent variable. In this lesson, we'll be dealing with two major regression, which is linear regression and multiple regression. Linear regression, being linear regression, it's a type of regression analysis where the relationship between dependent variable and one or more independent variable is assumed. Logistic regression is a type of regression analysis that is used when a dependent variable is categorical or binary. It is used to predict the probability of an event occurring based on the value of an independent variable. I'll explain furthermore on that when we get to regression. And logical regression, logistic regression. Now let's move to our linear regression. Our linear regression tries to find the linear representation between two variables, x and y. Y equals to function x, or y equals a plus b plus x. This can be c plus c plus e. If I would the slide down, you'll be able to see what I'm saying because I wrote it there. Now, it's important to note that simple linear regression assumes a linear relationship between two variables that other factors may also influence the dependent variable that are not accounted for in the regression analysis. Now, as I said, there are many types of analysis. There are many types of regression. And mainly what we'll be using here, although it's linear regression, we have polynomial regression, we have logistic regression. We have regressions like that. There are more regression. We have rigid regression. We have lasso regression. We have Bayesian linear regression. We have decision tree regression, and random through regression. Now, for example, mainly using this kind of regression, except if you are using a paid tool. Like I said, if you are using solver before you can be able to access more regression, but linear regression should be at least the highest that will be asked for any other final student to do or to do for your project. If I don't think that anybody outside statistics are using logistic regression or time series. So we move into simple linear regression. Simple linear regression is finding the relationship between a variable and the dependent variable and an independent variable. And right here is still the same thing we use for our multiple linear and single linear. What the difference is, there will be either two columns here and one column here. But for simple, it's just one column and one column. And let's say, okay, let's find the relationship between temperature, which is A1 to AH, and then our price of ice cream. There should be a very strong relationship between it, V8. Then our confidence interval is 95, as I said before. That means we want 95% truth. Our output range, choosing H, 8. Then we have our residual plot, our standard residual line fit plot, and a normal probability plots. These are plots that we can also use to understand the data, and it's by chance you can choose to use it and choose not to use it. Now, there are some of them that will not be really important, but just to show you everything, I'll add them to it, and then I press OK. So all I have to do is just to wait a little bit, and it will show here. The linear relationship is between container numeric. Okay, I selected labels now. Okay, now because I'm using price of ice cream, I have to change this to general. And this is something you have to note if you are doing if you are using your analysis. You cannot use prices. You cannot use prices because right now it was set to yin, and the regression analysis will not preserve it because it's different from general. It's an accounting setting. So what you do is change them back to general number, and then you can just put the price tag at the top here. So let's see what it does now. What is that? I mean, this network is affecting it. Okay, now network is affecting it because it should have preserved label here, but since it didn't preserve it, let's move up. So let me extend it. Network is really against me, but let me let it load. So now we have our, if you go back to the slides, there was an interpretation of results there, which will show you the use of every single thing there. Now, of course, our regression and our residual, we should know your X and Y. Our F, our significance of F. And I said now, since we are doing analysis and for the simple regression analysis, is F test that we use to check out the significance of our analysis, find our F test. And I've said before, I've said our criteria for our F test, but still let's see the detail. These are our significance, our intercept, and our price of ice cream, which is our these are beta naught, which is our A in the situation, and this is our B. Let me do this to show. This network is allowing me to slow down. So here we have it, our lower 95%. Now this residual output is not really needed. You're not going to need it in any situations. And what does this is you just combine it with this to check out the actual value. What it is, it predicts value. So number one, we have 21, we have 20, we have 20, we have 21 here, we have 26, we have like 27 here, we have 30, we have 29 here. What it does is just predict our value for us, predict our temperature value, and we don't really need it. Now let's move to our plot first. And these are residual plots. I said you will not be needing this. The price of ice cream line plot. This shows that okay, from now it shows that now like this now this can actually represent a kind of covariance because they are both increasing together. And these are normal probability plot, which is also increasing. So what this brought up now for us is our regression statistics, our multiple R, which is the multiple correlation coefficient, is the measure of strength and direction of the linear relationship between the dependent and all the independent variables. It is the range of -1 to +1. +1 indicates a positive relationship, -1 indicates perfectly negative relationship. Then we have our R squared. Our R squared is the measure of proportion of the variation in dependent variable that can be explained by the independent variable. Now I can go on and on about this, but every single thing that is here, you can check them out in my interpretation of results for on my slides. So it's not waste time. Sorry. Our standard error is the measure of variable and uncertainty of estimated regression coefficient. It measures the average amount of the estimated regression coefficient deviated from the true regression coefficient. So that's exactly how you get your simple linear regression, and this is exactly how it will come out. So with this, we can also move to multiple linear regression. Now, multiple linear regression and simple linear regression are almost the same thing. The only difference is you having two more variables. Let me remove this. This is of no need. Excuse me a little bit. Now, as I said, multiple linear regression is also the same thing as our single linear regression. The only difference is the column for X now has more than 2, 3. Now, I don't think I'll be using the plots here now. Don't need. I just need to show you what the plot is and how the plot works. Let me remove all this. It's not needed. Give me this bit of time. Now we're using temperature as our independent variable, and we're using price of ice cream and unit sold as our independent variable. This one will be delayed. Let me continue. So what we do here now is simple. Instead of using P1 to B8, we use C8 instead. And so that's just the difference in where you put them in Excel and use. Please, are you still hearing me? I was talking to myself.
I can hear you, please. Continue. Okay. Yes, okay. Yes, continue.
I think I'll stop at multiple linear regression, or because network is not really good again. So what I did here now was, let me move H to 0. Okay, let me put Q. I press OK. So I'm waiting for it to actually show. And you see it's already shown. Now the difference between the two It's just actually this. And of course, the interpretation of all these ones are already written down in the book, so you can just check my slide for it. We have our now, you see the difference now. If you can check this, we have our intercept, which is this. This is our alpha, our A, or our beta naught. This is our beta 1. I mean, this is our beta 1, and this is our beta 2. So it can also enter into the formula, which is x equals to beta naught plus beta 1 x1, beta 2 x2 to beta 1 x1 plus e. So you got that one like that. You got your p-value, you got your f, and your f counts if you are going to be doing an hypothesis testing. And this is exactly how you do your multiple linear regression. It's just the same way you do your it's just the same way you do your first simple linear regression. Now check this one out. See the predicted values from the observation. Now we have 28 for temperature, we have 20, so it shows that okay, now the prediction is somewhat inaccurate by a long chance here, which is showing that the relationship it's having with one of the variables is not very strong as the other. So now this is everything you actually need to know on how to do Excel, how to use regression on Excel. Because of this package is actually free and you can easily get it. Now, I really advise you to read more on the terms and interpretation of all this so that you can know the exact meaning of that. You'll be able to actually properly understand and properly use it in the future. Now, I would have really loved for us to start our logistic regression here, but because our logistic regression is going to be different, let me change the screen and show you how logistic regression is. Okay.
Hello, we can't see your screen. Oh. Okay.